Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. Hey Kooks, this question says, test the equation y equals 3x squared minus 5 for symmetry. So there are three types of symmetry which most classes test on. The first is x-axis symmetry. So to test x-axis symmetry, you plug in negative y for y, and if it equals the original equation, then it's symmetric about the x-axis. An example of a graph that would work is x equals y squared. Notice this graph is symmetric about the x-axis because if you folded this guy up, it would land exactly on itself. Next is y-axis symmetry. To test for y-axis symmetry, you plug in negative x for x, and if it equals the original equation, then it is symmetric about the y-axis. The most famous example of an equation that is symmetric about the y-axis is y equals x squared, your standard parabola. Notice if you folded this guy over the y-axis, it would land right on itself. Therefore, it is symmetric about the y-axis. Next, the next type of symmetry is origin. To test origin symmetry, you're going to plug in negative x and negative y for x and y, respectively. And if it equals the original equation, then the graph is symmetric about the origin. Now, the most famous equation or graph that is symmetric about the origin is y equals x cubed. So here is a look at what that looks like. Notice like the point, like 2, 8 is on this graph. So if 2, 8's on the graph, then negative 2, negative 8 will be on the graph as well. All right, now that we know that, let's go ahead and test our equation given for all three types of symmetries, and we will see which, if any, that it's symmetric to. So here's a reminder of the procedure for each one. So let's start off with x-axis symmetry. So here's our original equation. We are going to plug in negative y wherever we see a y. So here's our y value. So I'm going to plug in here in red just to kind of show I'm plugging in a negative y. And then we'll simplify this and see if it equals the original. So the original is this guy. So I'm going to times both sides by negative 1 to get a positive y here. So let's go ahead and times both sides by negative 1. I'll put negative 1 here, negative 1 here. So on the left side, we have negative 1 times negative y, which gives us positive y. And then since we're timesing this side here by negative 1, the signs just change. So we're going to end up with negative 3x squared plus 5. All right, so remember, for any symmetry to happen, the equation has to be exactly the same as the original. Is this equation here for y exactly the same as the original? No. So because of that, there is no x-axis symmetry. All right, so there's one of the three answers. Next, let's move to y-axis symmetry. So we'll bring down our equation. And now we are going to plug in negative x for x. So we'll plug in negative x right here for this x. So let's go ahead and do that and see what we get. I'll plug it in red so you can kind of see what's happening there. Now if we simplify negative x squared, that's negative x times negative x, which is x squared, positive x squared. 3 times positive x squared is just 3x squared minus 5. So there's our simplified equation. Is this exactly the same as the original equation? Yes, it is. So therefore, there is y-axis symmetry. So we'll put that in green. So y-axis symmetry. So we'll go ahead and box that. So it worked for y, but not for x. Now let's test the origin. So for the origin, we're going to plug in negative x and negative y for x and y. So let's see what happens here. All right, so let's simplify. The left side is just negative y for now, so we'll keep that. And then the right side, we have negative x quantity squared, which is negative x times negative x, which is positive x squared, times 3, which gives us 3x squared and then minus 5. All right, I'm going to times both sides by -1 to make this y positive. So I'll do that in blue. We'll just write the -1 here. All right, on the left side, we have -1 times a negative y, which equals positive y. And then whenever we multiply a bunch of terms by a negative, it just switches the signs of the terms. So this will now become -3x squared plus 5. So now we have to compare that to the original equation. Is this exactly the same as the original equation? No, it's actually quite different. Both signs on the right side here are different than the signs on the right side here. So this would be a no as well. So we'll say no origin symmetry. All right. So those are our 3 answers. So the only one that worked was y-axis. So this graph is symmetric about the y-axis, and that's it. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.